Hi coders, CS Time channel here, and this video discuss about how to delete a node at the end of a doubly linked list. Let's see the logic. There are two possible conditions of doubly linked list when you are about to delete a node. The first condition is when the list is empty, and the second condition is when the list is not empty. When the list is not empty, there are two possibilities. List has only one node or list has many nodes. When the list is empty, head pointer and tail pointer point to the null. Therefore, when you try to delete a node in this situation, your program should throw an exception. When the list has only one node, the head pointer and the tail pointer point to the same node. Here I have A. Therefore, when you wish to delete the node, you should instruct the head pointer to point to null and the tail pointer also point to null. Your doubly linked list after deletion will look like this. When the list has many nodes, then your doubly linked list will look like this. The head pointer and the tail pointer point to different nodes. And when you wish to delete the last node from the doubly linked list, then you will need another pointer to help you. Here I use temp. Temp should point to the node pointed by the tail. So we instruct the temp to point to the tail. By giving this instruction, then the temp pointer will point to the node pointed by the tail, like this. Next is to instruct the bnext pointer, which is this, to not point to C or point to null. The instruction will look like this: tail.previous.next equal to null. By giving this instruction, then the doubly linked list will look like this. The bnext pointer point to null. The next job to instruct the tail pointer to point to the previous node, in this case is B, because when you delete the last node, then the last node in our doubly linked list will be B. Then we can give this instruction: tail is tail.previous. By giving this instruction, then our doubly linked list will look like this. The tail point to the B. The next job is to instruct the previous pointer belong to the last node to not point to the previous node. We can give this instruction: temp.previous, because C is pointed by temp. So temp.previous equal to null. By giving this instruction, the node that contains C will look like this. Now our doubly linked list will only consist of A and B, where the first node, which is A, pointed by head, and the last node, which is B, pointed by tail. And the C node is already untied from the doubly linked list. Let's see the Java implementation. In the previous video, I showed you already how to create a method to delete the first node from the doubly linked list, like this. In another video, I also show you how to create the class of the doubly linked list, where it has two pointers, head and tail, and it has one variable called length that I declare it as integer to know the size of the doubly linked list. And then to create the node itself, I declare data as character as well as two pointers, next and previous. I also created a method to return the size of the doubly linked list, and I also created a method to know if the doubly linked list is empty or not. Before we write the method, let's run this program to know how it looks like. So this program do insertion in the beginning. I test it by inserting A and Z, and then I display it, and here is the result. And then again I do insertion in the middle, and I inserted C and D, and then I display it, and here is the result. In the previous video, I did the deletion, which is delete first, and then I display the result. And after deleting the first node, the doubly linked list would look like this. Now let's write the method to delete the last node from the doubly linked list. So the same with delete first, I will also declare it as public list node delete last. And then according to the concept that I explained, the first condition of the doubly linked list Maybe it's empty. So we will call the empty method. If it's empty, we cannot delete it. Therefore, I need to throw an exception here. No such element exception like that. Another condition, maybe the doubly linked list consists of one node or many nodes. Therefore, we need the help of temp pointer that I declared it as list node here. We instruct it to point to the node pointed by the tail. If it only has one node, the head and the tail point to the same node. So we check if head equal to tail. It means we only have one node. Therefore, we will instruct the head to point to the null and the tail also point to the null. Otherwise, then possibility is consists of many nodes. If it consists of many nodes and we want to delete the last node, then we will instruct the tail dot previous dot next, which is the second last node next pointer must point to the null. And then we will tell the tail to move to the previous node. Now we can tell the temp, which is consists of the last node dot previous, to not point to the previous node, so equal to null. Because we delete it, we want to reduce the size of the doubly linked list. Now we can return the node that we deleted. To test it, then I will copy this and then I'll change it to delete last. Let's run it. Here is the result. In the previous video, we do deletion, which is the first node to delete. So the first node has been deleted here. And just now, we wrote the method to delete the last node. The last node here, which is Z, has been deleted. So this is the result. If you learned something from this video, please subscribe and like for more videos. Thanks for watching.